Welcome to Dynamic Coaching Center. So we will be seeing throughout this series about the staff selection commission previous year question papers. I'm just giving you the glimpse of the idea, and the class videos will also be posted very soon, and you can watch those things and try to crack this exam. So this is where we have left out, and we were seeing about the thermodynamic topics, and related to thermodynamics, what are all the previous year question papers, what are all the previous questions which has been asked in the staff selection commission is what we are seeing. And this question has been asked in the year 2010, where the question is the work done in the expression of the gas from volume V1 to V2 under constant pressure P is equal to. So basically for constant pressure process, what is the work done expression, what they are asking. So option A, it is 0, option B, P into V2 minus V1, option C, P into V2 plus P1, and option D, P into V2 divided by V1. So these are all the four options given. Okay. So basically, we know that small change in work done will be calculated as integral PdV. So this is what the general expression which has been applied for calculating work done for any closed system. So they have given that at constant pressure. So pressure constant means you can take that out of the integration. So it would be pressure integration of dV, for which they have given the volume V1 to V2 also. So if you do so, it would be dV integration would be V, and if you substitute the upper limit minus lower limit, you will end up with P into V2 minus V1. So this is what the work done expression which you are getting for constant pressure, because it is constant, I'm taking this outside. It is not function of volume or temperature. Okay. So I can say that option B would be the correct answer. So let's move on to the next question. So this is the next question. Heat and work hour. So already we have seen in the previous session about the point functions and what are all the questions related to that. Okay, and path functions, heat and work are generally path functions. So heat and work are option A point function, option B system properties, option C path functions, and option D intensive properties. Okay. So the correct answer is very simple. All the flowing quantities are going to be path functions. So I can say that heat and work are path functions because they depend upon the path they follow between two end states. So if you have a TS plot, like for instance in the previous session we have seen what is the path which is going to be taken. So accordingly the heat and work will take place. Okay, so it can be reached through n number of process, n number of ways. Okay, so I can say that heat and work are generally path oriented functions. So option C is the correct answer. So we'll move on to the next question. So very simple one. They have asked in the same year 2010. The term NTP stands for. You might have seen this in many of the textbooks. So four options have been given. Option A, nominal temperature and pressure. Option B, natural temperature and pressure. Option C, normal temperature and pressure. And option D, normal thermodynamic practice. Okay. See, generally, the term NTP stands for normal temperature and pressure. So temperature normal is 20 degrees Celsius actually. So if you add to plus 273.15, it would be 293.15 Kelvin. Similarly, pressure for this normal temperature would be 1 atmospheric pressure, which is actually 101.325 kilopascal, or you can even represent in bar. So I can say that this is actually option C. NTP stands for normal temperature and pressure. So the next question is, the same year 2010, the first law of thermodynamics is a law of. So what is this? It's a very simple question. Option A, conservation of mass. Option B, conservation of energy. Option C, conservation of momentum. And option C, conservation of heat. So we all know about the first law of thermodynamics is actually law of conservation of energy. So energy can neither be created nor be destroyed, but it can be transformed from one form to another form. So it states that the first law of thermodynamics states that the total energy of an isolated system in the sense it is not at all interacting with the surrounding. Okay. So for that system, I can say that the total energy is constant. So energy can be transformed from one form to another form, but neither it can be created or destroyed, right? So I can say that option B is a correct answer, conservation of energy. We will move on to the next question. So again related to first law of thermodynamics in the subsequent year of 2011, first law of thermodynamics asserts the following is the thermodynamic property. First law of thermodynamics actually asserts that the following is a thermodynamic property. Four options: option A, entropy; option B, internal energy; option C, temperature; and option D, pressure. So we'll go for the first law of thermodynamics. If you remember the first law of thermodynamics, we know that change in heat transfer will be equal to change in internal energy plus change in work done. Okay. So this is heat and this is work. Both are path functions and this is a property which is a point function. So first law of thermodynamic expression has been written and it is said that internal energy is a property of the system. So option B would be the correct answer. So the next question is, for a closed system, the difference between heat added to and work done by the system is equal to. You have to be careful with these words because if you take any closed system, whether the heat is flowing into the system or out of the system, work is flowing into the system or out of the system, will actually makes a new sign convention, right? So if there is a system and if it receives heat, it is considered as positive. If there is heat loss, it is considered as negative. Similarly, there is another closed system where it receives work, which means it is work done on the system, which is negative, and this is work done by the system, which is positive. So we have to be careful with these words. So work done by the system and then heat added to. So heat added to. Okay. So for a closed system, the difference between this Q minus W is equal to option A, enthalpy; option B, internal energy; option C, Gibbs function; and option D, flow work. It has been asked in the year 2011. So we know that your first law of thermodynamics, just now we have seen in the previous question also, dq is equal to du plus dw. So they have asked about the difference between, you don't need to do any sign conventional changes because they have said that heat is being transferred to the system, which is positive, and work is being done by the system, so again it is positive. So leave it as such, you don't need to add any negative or positive sign. But they have asked about the difference between heat and work. So which means dq minus dw will be actually equal to du, which is nothing but internal energy. So I can say that option B would be the correct answer, internal energy. So we'll move on to the next question. So which of the following gases has the highest value of characteristic gas constant R? So we know about the perfect gas law, PV equal to MRT. In that, which is having the highest value of R is the question. Okay. So option A, carbon dioxide; option B, sulfur dioxide; option C, oxygen; and option D, nitrogen. This question has been asked in the next year of 2012. So for this, you have to know about the molecular weight of certain components. Okay, so I can say that my characteristic gas constant R is being related to universal gas constant by this expression. So which means my characteristic gas constant, my question is which is having the highest value of characteristic gas constant. So for the highest value of characteristic gas constant, this m is nothing but the molecular weight. So molecular weight should be low. So now let's work on that. So we have been given with the options of carbon dioxide, sulfur dioxide, oxygen and nitrogen, right? So for carbon, the molecular weight is 12. For oxygen atom, it is 16. For sulfur, it is 16. And then for nitrogen atom, it is 14. Now we'll find out the molecular weight of carbon dioxide. So for carbon, it is 12. For oxygen atom, it is 16, but 2. So it would be 16 into 2. So totally it is 44. Similarly, molecular weight of sulfur dioxide, sulfur 32 plus O2, just now we have found it is 16 into 2, again 32, so it is again 64. And then molecular weight of oxygen, it is 16 into 2, so it is 32. And molecular weight of nitrogen, we know it is 14 nitrogen atoms, so 14 into 2, so it should be 28. So out of all these things, whichever is having lowest molecular weight will have the highest characteristic gas constant. So the minimum is nitrogen, so I can say that nitrogen is the one which have the highest gas constant. So nitrogen is the answer. So option D is the correct answer. So we'll move on to the next question. The molecular kinetic energy of the gas is proportional to option A T power 3 by 2, option B T square, option C T, and option D T power 1 by 2. So this question has been asked in the year 2012. So we can say that the molecular kinetic energy of the gas, so the molecular kinetic energy of gas is directly proportional to temperature alone. So option C is the correct answer, not related to any root or square. So we'll move on to the next question. Which aspect does not pertain to free expansion process? So we know already, we have seen for free expansion the work done is 0. Which aspect does not pertain to a free expansion process in the year 2012? Option A, pressure remains constant. Option B, no change in temperature of the system. Option C, no gain or heat loss. Option D, work done is 0. Okay. So the thing is, it is said that it is free expansion. So in a free expansion process, if you take free expansion process, we know that the work done is 0. But the question asked was actually which aspect does not pertain to free expansion is what the question is. Okay. So I can say that the pressure does not remain constant. So which means option A would be the correct answer. So what you can do is, for free expansion, you can note down for few points so that the same question will be repeated here and there. So it will be very easy to choose. So this is the next question which has been asked in the year 2012. The isentropic expansion of initially superheated steam through the nozzle may be approximated by the given equation. See, they have said it is a steam nozzle, okay, and the isentropic expansion is being given, okay. So what is the correct equation representing the isentropic expansion of steam through the nozzle? Option A, PV power 1.135 equal to constant. Option B, PV power 1.3 equal to constant. Option C, PV equal to constant. And option D, PV power 1.2 equal to constant. So I'll be giving you the exact thing. See, for example, we have a general equation PV power n equal to constant. Okay. So for dry saturated steam condition, dry saturated in the sense we know that the dryness fraction is 0. Sorry, dryness fraction is 1, completely dry. Okay. For that, your N value would be 1.35. And similarly for superheated steam, your N value would be 1.3. And for air, you can say that your N is 1.4, which everyone knows, right? So that it becomes PV for gamma equal to constant. So if you just read to the question, they have said clearly that it is initially superheated. So I can say that 1.3 should be the answer, which means option B is the correct answer. So we'll move on to the next question. When neither mass nor energy is allowed to cross the boundary of the system, it is called. Question has been asked in the same year 2012. Option A, isolated system. Option B, universe. Option C, closed system. Option D, open system. We know about the closed system and open system. In open system, mass is also allowed, work is also allowed, heat is also allowed. And in closed system, you have heat and work alone is allowed, whereas mass is not allowed. But here they are asking about both energy, which means both work mass, work heat should not be allowed to cross the boundary, and mass is also not allowed to cross the boundary. Then that system is called as. So the basic first law of thermodynamic expression itself will actually carry on this. So when neither mass or energy is allowed to cross the boundary of the system, that particular system where Q work both falls under energy and also mass. If anything is not allowed to cross, then that type of system is called as an isolated system. So I can say that option A would be the correct answer. Okay, now we'll move on to the next question. So which of the following entities is not a thermodynamic property? Okay. So option A, specific volume. Option B, heat. Option C, pressure. Option D, temperature. So we can say that volume, pressure, temperature, everything is actually a property, right? Whereas this heat is not at all a property. Heat and work are actually path functions. They are not point functions. So they are not a property. Okay. So option B is the correct answer. So you can just watch out this series completely covering all the preliminary questions of past 25 years of Staff Selection Commission JE. In addition to this, we are also planning for the conventional papers also. Okay. So for any useful information, you can watch this series. Thank you.